In the last lecture, we're going to cover some absolute value with some inequalities. And so the first one, whenever you're solving equations with the absolute value, we're going to go ahead and do it once. Step one, we'll do the positive 1 in front. So you just drop the absolute value and you put a positive 1 in front, but having positive 1 in front of the parentheses really doesn't do anything. So you're just solving that equation and you go minus 2, divide by 3, and you get x is 5/3. And the second step is to do the negative, and I start with -1 in front. Other people shortcut it. Sometimes a little different, but I like to put the -1 in front because when we get into inequalities, it helps us with the symbol. So when I divide by -1, I have 3x plus 2 is equal to -7. And now I subtract 2, I get -9. And when I divide by 3, I get x is -3. So those would be my two answers. And you can go to a graphing calculator and do something like put this in y1 and put this in y2 and do second trace, calculate an intersection to go ahead and make sure it's right. So pause the video, do example 2 now, and come back and check your answer. So pause. So here's the positive side. Just drop the absolute value, solve it, get 8. And you can see they put a negative in front. This time they distributed, which is fine. I always divide by -1. It's the same thing, but when you do this, you'll get -3. And of course, you should always be plugging in. 2 times 8 is 16. Minus 5 is 11. Absolute value of 11 is 11. Put the -3 in. 2 times -3 is -6. Minus 5 is -11. -11 is the distance from 0 will be +11. So that works. So you can see the two answers here. On the positive side, you get 8. And with that negative in front, they distributed, which is totally fine. I always divide by -1, but you'll get the -3. And when you plug them back in, it should definitely work. All right, so this one definitely more advanced, but you can see the absolute value is isolated. So if there were numbers anywhere here, we'd want to get rid of them, send them to the other side. So step 1, I'm just going to drop the absolute value and do this. And then step 2, I'm going to drop the absolute value, but I'm going to put a negative in front. And so what you're seeing here is now we're working with quadratics on both sides. So I need to move these terms over, and you have x squared plus x minus 6. That will factor into x plus 3, x minus 2, and I'm getting -3 and 2. On this side, I would divide by -1, and I have x squared minus 3x. Like you saw in the previous problem, you can distribute the negative if you want. I just don't want to make my x squared negative. So now it's positive 4x and a -6, and I have to bring those over. So it's x squared minus 7x plus 6 is equal to 0. And again, it's quadratic formula. You can easily use a quadratic formula, but I can see that this would be x minus 6, x minus 1 factoring. And so I have 6 and 1. Now, there's a lot of plugging in to do on this problem, so I'm going to go to the calculator just to show you. It might be a little easier to find those answers. So this is what it would look like. So I've typed my two functions in, and remember on absolute value, you have to hit the math button, and then math, and you slide over to number, and there's absolute value, and on my calculator it puts absolute value bars. So if I graph this, absolute value. It wants to go below, but because the absolute value has to pop back up. And so what you're seeing is there only one answer here, and there will be one up here. So two of my answers don't work. So going back here, if I plug it in, let's start with -3. -3 squared is 9. 3 times -3 is -3, and so I end up with 18. 18 under the, or inside the absolute value. And then when I plug in -3 here, I get 18. -4 times -3 is +12 plus 6. So this one works. If I try the 2 squared is 4, and 3 times 2 is 6. So when I say 4 minus 6, I get -2 inside the absolute value. So that will end up being just +2. And then this one, I do the 2 here, and I get -8 plus 6, I get -2. Well, 2 does not equal -2, so this is a no. Plug in the 6. 6 squared is 36. Minus 18, so I get an 18 again in absolute value. That'll work. And -4 times 6 is -24 plus 6 is -18. So the absolute value has changed it to positive, but I need -18 over there. So this is a no. And then the last one is this 1. And when I plug it in, 1 squared is 1. Minus 3 would be -2 inside the absolute value, so that'll be +2. And -4 times 1 is -4 plus 6 is also 2, so that's a yes. And so when you look, -3 and 1, going back to the graph, does look like maybe -3 would be over here, and it's going to hit up there, and right above 1. So I'm pretty confident my answers are good. All right, so now let's find the next example. So example 4, DIY. Go through it, similar to what we did. Double check your answers. So pause the video now. So again, absolute value, do the positive, do the negative. You want to find both quadratics. You should have this quadratic and this one. And you'll need the quadratic formula for this one. And if you graph this, you'll see I think these two are working. The one that doesn't work is this -3. So the graph helps you determine, even if these are not so nice, be confident that they're going to work. So now we're getting into some inequalities. So remember, just use your algebra. So I'm going to add 7 on both sides, and I will subtract 3x on both sides. And I'm left with 2x there. That's gone. That's gone. And this is 16. And I divide by 2. And any x that's greater than 8. So again, parentheses, 8 to infinity. I use parentheses because it's just greater than. Pretty easy. The next example is similar. So I would subtract 6. And then when you divide by -2, we have to remember to flip our inequality symbol. Technically, you flip when you multiply or divide by negative. You've heard a lot when you divide by negative, but it's also multiply because, so that's my answer. I'll explain it in a second. X's that are less than or equal to -6. So this would be something like -infinity up to -6. And we're going to do a square bracket because of the equal to. If you look at 10 divided by -2, I get -5. But I can also take 10 times -1/2 and get that same -5. So if you multiply or divide by negative, you need to flip the inequality. So there's a DIY. Pause the video, try that one, and look at the answer. So pause now. And in this case, with that negative 3 halves, there are different ways. This one multiplied by 2, then divided by negative 3. You could multiply by the reciprocal negative 2/3 if you wanted. But you can say x is greater than or equal to negative 8/3. And you would write it like this in interval notation. This one's not bad either. It's just got a couple different symbols. So work down the middle. You will add 1 on all 3 spots, and you have negative 2. And then we can divide by 6. So I get that reduces to negative 1/3. That's 2/3. So that is fine. That would be the domain or solutions to this. You could also do square bracket on the negative 1/3 to 2/3 with just a parentheses, looking at the 2 symbols. Oops, I forgot to write my less than there. But this is what either of those answers is totally fine. So in these next examples with absolute value, we are going to kind of do it similar than what we were doing earlier. We'll do step 1 and step 2, but if we show understanding to the problem, we can shortcut it. Now, if you have to have a distance less than 2, less than, meaning if there's a spot here, you can only go 2 this way or 2 this way. So the answers are always inside the critical values. So you can go ahead and take this and make it negative 2, keep the symbol pointing the same way, and then put the positive 2 there. So that's a little bit of a shortcut. And now when you do this, you add 5 on both sides, and you get 3 and 7. But the idea is you can't go outside of the critical values. So if you found the critical values of 3 and 7, doing it step 1 and step 2, you're going to get this to work anyway. With greater than, if I put my x in the middle and found the critical point, whatever it is, and found another critical point, what this is telling me is that my distance has to be greater than 6. So I can be out here or out here. I can't be in the middle. I have to be to the outside. My distance always has to be, like, if this distance is 6, we have to be outside it. So when you do step 1, you go x minus 4 is greater than 6. And step 2 would be x minus 4, but we're going to put the negative in front. And the nice thing over here, like I did earlier, is when you divide by negative 1, I just get x minus 4. But now I flip my inequality, and now you can see that you have to be less than negative 6 there. So now when I solve these two things, I can just add 4 and add 4. And I get x is greater than 10. And over here, I would add 4 and add 4, and I get x is less than negative 2. So on a number line, 10, open circle, negative 2, open circle. We're talking about the stuff outside. So you could say negative infinity to negative 2, parentheses, 10 to positive infinity. So that'd be a good way to write that answer. So there's a DIY. So go ahead and pause the video and try that one. That one's almost identical to 6. So again, if you do step 1 with a positive, this one, the person that did this notes, they shortcutted this. So they wrote x minus 20 with the negative in front and divided both sides by the, no, they didn't. This one. Sorry. So this would have been the one that they did the negative 1 in front of. And so when they divided, they flipped the inequality and put the negative there. This one is the positive. They just wrote down x minus 20 is greater than 4. But what you're going to get is 16 and 24. And because it's greater than, you have to always be more from the center, I guess. So you're looking at outside answers. All right, the last couple examples, we're going to find the critical values. I'm going to skip using the box because we just got done doing chapter 2, and you should know the shape of these graphs. So if I simply factor this, it might take you a couple times, or use the quadratic formula. But because of the 2 there, I can put 4 here and 3 there. And if I make the 4 positive and the 3 negative, that actually is your factoring. And so my critical values turn out to be positive 3/2 and negative 4. So if I draw a number line, and I'm going to put an open circle at 3/2 and an open circle at negative 4. All you have to do is find out where are you getting negative outputs. So where do you get negative outputs? Well, if your graph is x squared and it's positive, you know it is a U-shaped graph that does something like this. Well, here it's negative. Over here it's positive. Over here it's positive. So that tells you right there what your interval is. You want all of the answers between negative 4 and 3/2. And because it's strictly less than, just put a parentheses around it and you're all done. So go ahead and pause the video and do the next DIY. So in the DIY, the first key is to go ahead and find it. Again, it factors, okay? So you have negative 4 and 1/3. You can also use go ahead and use the quadratic formula. But when you look at the number line, negative infinity to negative 4 to 1/3, 1/3 to infinity, those are your intervals. And you could pick a number to try. And when you put in negative 5 into the factors, you get a negative 16 and a negative 1, but we really don't care what the number is. It's a negative times a negative, or positive overall. And if you pick 0, any number in the interval will work, but 0 is easy to work with. You can actually plug that into the beginning, and you're left with negative 4. So it's negative. And then do the same thing, 1/3 to infinity. I like to work with 10. 1 is fine, but putting a 10 here would have been 30, which is positive. Put a 10 there, that's 14. So you end up with a positive. So right here, it's telling you, you want a positive number. So that and that sign. So it tells you the first interval and the third interval. The way I taught it earlier was, this is a parabola that is just simply opening up. It's x squared with a positive 3 in front. And where does it go above? Well, clearly in the middle, it goes under the line, or negative, positive out here. So I don't know that we need the table. We can just go ahead and do that. Square brackets, because it's equal to, infinities always get parentheses. All right, so the last problem, again, big table there. If you want to fill it in, you can. It's a little more stuff to keep track of, but let's try a factor by grouping. And so if I take out an x squared, let's see what happens. It leaves behind 2x and a negative 3. And on the next one, I could take out a 16. So if I pull out a 16 negative, it would leave behind 2x and also negative 3. So that worked. And these two things are the same, and we did a factor by grouping earlier, so in lecture number 1. So that can come out to the front. And then it leaves behind the x squared minus 16. And so the final factoring would look something like 2x minus 3, x minus 4, and x plus 4. And so my critical values are 3/2, 4, and negative 4. So if I go to a number line, and I put them in order, I would put -4 first. Then I would put 3/2. And then I would put +4. Now notice it has the greater than symbol that does not equal to, so I used open dots. And then also this is x cubed with a positive, so I know it goes down, or starts in the bottom left, goes up, down, up. Sorry about that. And so when you look at this graph, they're definitely below the line there, above the line there. Outputs are below there and above again. And right here, we're looking for positive answers. Things that are greater than 0 are positive. So my answer goes -4 to 3/2, parentheses around both with a capital U for the union, 4 to infinity.